this week we started 5.8, which is the Earth, Sun, and Moon. All right, and I just want to kind of recap a couple of the big key factors of Earth, Sun, and Moon. If you'll remember, the Earth, that's where we live. It's spherical, okay? It's got water in all three states. It rotates around its axis and revolves around the sun. It is the third rock from the sun, third planet from the sun, and it has an atmosphere, okay, which is responsible for a whole lot of stuff. So that's what we're going to talk today about, is the Earth's atmosphere, and I'm going to get to that in just a second. The sun, however, it's also spherical, okay? It is the center of the solar system, of our solar system. It is the closest star to Earth. It's an average size star, so there's nothing really special about its size. It's just a regular star. It's just the one that we're closest to. It provides heat and warmth for the planet. It also has an atmosphere. It has gas. It's a gas. Whereas Earth is rocky, it's a solid. The sun is a gas. It's made of helium and hydrogen. And then the sun is also spherical. Okay. Finally, we've got the moon. It has a small amount of gravity, very small. It has phases, so hopefully you've been doing your lunar calendar. It rotates as well. It also revolves, but it revolves around the Earth, okay? And it has a limited atmosphere. And that's what we're going to talk about today, is the atmosphere of both the Earth and the moon and how it's different and how they affect those planets. So we talked about how the Earth has this atmosphere, and it's kind of like a warm blanket that kind of goes over it. It protects the Earth from a lot of the harmful rays that the sun kind of can send down towards the Earth. It also keeps the planet warm, so that's why I kind of describe it as a warm blanket. It keeps our temperature from fluctuating too much. So when it gets cold, it can get really cold, but it doesn't get extreme amounts of cold because that atmosphere is there to kind of keep the Earth a nice, cozy, livable temperature for all human life. The moon does not have that. Okay, the moon does not have that, so the temperatures on the moon are extreme. When the sun is hitting the moon, the daytime in the moon, it's very, very hot, and nighttime in the moon is very, very cold. So that's one big difference. The second thing that the atmosphere does is it protects our planet. So while the Earth has been hit with large meteorites, a lot of that has not been able to penetrate our atmosphere because it has a hard time breaking through. That atmosphere, it's a warm blanket, it's a protective blanket, and it also prevents any kind of space material from getting through. Now, large ones can get through. The Earth definitely has been struck by meteors and asteroids and stuff like that. But a lot of the smaller ones and a lot of different debris doesn't get through, and that's because of the atmosphere. Now, the moon, on the other hand, has a very limited atmosphere. So the moon can get hit with different size asteroids quite a bit. And that's a big difference between the Earth and the moon. Another thing to think about is that the craters in the moon are there permanently for a long period of time because weathering and erosion look different on the moon than they do on the Earth. That process of breaking down rocks, it looks very, very different. Whereas on the Earth, rocks can break down, and it's a process that can take millions of years. So while we've been struck by meteorites, a lot of those sites where we can see them, they've been weathered, the rocks have been broken down and eroded. That does not happen on the moon as in the same manner as it happens on Earth. So today's experiment is all about atmosphere and how we go about, how the Earth goes about keeping its atmosphere. So, and what it does. So we've got our two planets here, our two celestial bodies. Here's the Earth, and you can see that it's the Earth because I've got water, and then I've got another tub in there that's for land, okay? And then this one is the moon. Do you want to get a little bit closer? And if you look at the top, our Earth's atmosphere, it's covered in this tape, but the holes are very, very small, okay? Whereas the moon's atmosphere is very, very open, okay? So what I'm going to do is I'm going to set these on the ground, and I want you to pay attention to how the atmospheres can protect our meteors and how they can protect the planet. So I've got all these little meteors right here, and I'm going to drop them, and then I'm going to let you see the impacts. So I'm going to drop one first on Earth. Here we go. That one just bounced right off. There's another one. Whoop, bounced into the moon tub. That one bounced right off. That one got through. So there's 1 out of 3 so far. There's 4. There's 5. 6. 7. So I had 3 out of 7 get through. Okay, 3 out of 7. So I'm going to regather up my meteors here. Some of them kind of went astray. 2, 4, 6, 7. Okay, I'm going to do the same thing, but now I'm going to do it on the moon side. And you can kind of see the difference already. There's one in there that bounced off the earth one. So here I'm going to drop our first one. There's our second one, so that one got through. 2. I'll try to drop it in a different spot. 3. 4. So that one took a bounce, but it still got through. 5. That one didn't make it. 6. 7. So of the 7 that I dropped, almost all of them got through. And if I were to take and peel this back, let's start with the earth one first. If I take and peel these layers of the atmosphere back, I have 2 that went in the water of the earth. Okay, you can see those 2 are in the water. But I have one right here that landed on the ground. And you can kind of see the shape right there. It's got some impact. Okay, there's some impact. But the size of it is relative to the size of my meteor. So it kind of makes you wonder how the earth would be affected if I had a really, really big rock or something that landed in it. So you can kind of see the meteor right there. Most of those bounced right off the top of the atmosphere. And now we've got the moon, okay? And the moon one is just got several in there. So we've got, oh, one right there. That one's a deep one. You can really see how deep it is. Look, if I were to stick my finger in it, it goes all the way almost down. See how deep it is? There's another real deep one. I was really able to get in there. Wow, that one's almost about halfway up my finger. There's another nice deep one. Here's one over here. Look, this one's even bigger than the one. You can even see the size of that one right there. So this kind of explains exactly why the moon's surface, this one even kind of, you can see it impacted right here, but then it even kind of rolled down a bit. So you can kind of see how the moon's surface is the way it is, how it got to be so, how all those craters on there, and how the atmosphere for the moon is really not doing a very good job protecting it. Most of our asteroids got in, and you can kind of imagine the size. A lot of these are very deep, and they were wide compared to our little asteroid here, and you can only kind of imagine how much deeper and wider they would be if it was a large one, how that's going to impact the surface of the moon. And then here with our Earth one, we had 3 that got in, but the majority went into the water, and then one landed on the surface, but you can even kind of see it was definitely not as deep as the moon one was. And over time, that's with weathering and erosion, that's going to be taken, and it's even going to be made more shallow. So the atmosphere is on the Earth and is on the sun, and it provides that protective barrier. But the one on the moon sure does let a lot of stuff into it. That's why the moon has been struck so many times with asteroids. I think now you have a lab to complete on STEM scopes about the crater size. So make sure that you made a note of that and all the different crater sizes that the moon one left versus the Earth one and the different characteristics between the two. All right, guys, we'll see you later. Bye.